In this video, I want to share some more interesting problems regarding the mathematical topic of primes, factors and multiples. I did a part 1, now I'm doing a part 2. So let's dive into the video. I'll focus on problem number 5. So if I read the problem, it says here are 3 lamps, lamp A, lamp B and lamp C. So lamp A flashes every 20 seconds, lamp B flashes every 45 seconds and lamp C flashes every 120 seconds. So the 3 lamps start flashing at the same time. So they start at the same time. So how many times in 1 hour will the 3 lamps flash at the same time? So you have to find how many times in 1 hour will they flash at the same time. So in order to find the time where they flash at the same time, you have to find the lowest common multiple of 20, 45 and 120. So if I just quickly do the lowest common multiple of 20, 45 and 120, in order to find the lowest common multiple, what I can do here is use the prime factorization. So if I first start with 2, I can divide 20 with 2, so I get 10. I cannot divide 45 with 2, so it remains 45. I can divide 120 with 2, so I get 60. So now I'll divide with 2 again because I can divide 10 and 60. So if I divide 10 with 2, I get 5. I cannot divide 45 by 2, so it remains the same. I divide 60 by 2, so I get 30. So I'll use 2 again because I can divide 30. So if I use 2, I cannot divide 5, I cannot divide 45 by 2, and I can divide 30 by 2 and I get 15. Now I'll use 3 because there is no more number that can be divided by 2, so I use 3. So I cannot divide 5 by 3. I can divide 45 by 3, I get 15. I can divide 15 by 3, I get 5. So I'll use 3 again. So I cannot divide 5 by 3. I can divide 15 by 3, I get 5. And I cannot divide 5 by 3. So now I can use 5. So I can divide 5 by 5. So I get 1, 1, 1. So if I use the prime factorization, the lowest common multiple will be 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 5. So 2 cube multiplied by 3 square multiplied by 5. So this is the lowest common multiple of 20, 45 and 160, or 20, 45 and 120. So what do I get? 2 cube is 8 multiplied by 3 square is 9 multiplied by 5. So 8 9 is 72, 72 5 is 360. So 360 is the LCM of those three numbers. So after 360 seconds, or if I divide it by 60, so I get what? 6. So after 6 minutes, after every 6 minutes, these 3 lamps will flash together. So how many times in 1 hour or 60 minutes will these 3 lamp flash at the same time? So if I divide 60 by 6, I get 10. So they will flash 10 times in 1 hour at the same time. So this is how you solve this problem. So in 10 times the 3 lamps will flash at the same time within 1 hour. So this is how you calculate the LCM and then figure out the requirement of the question. I'll now focus on problem number 7. So let's read the problem. It says there are some small cubes and some large cubes in a bag. So the cubes are red or the cubes are yellow. So the ratio of the number of small cubes to the number of large cubes is 4:7. The ratio of the number of red cubes to the number of yellow cubes is 3:5. So there can be a either small or large cube, either red or yellow cube, but there can be mixed. For example, small red or large red, small yellow or large yellow. So these are the possibilities of combinations. So in the first part, you have to explain why the least possible number of cubes in the bag is 88. So this is the problem that we will focus here first. So as you can see, the ratio of small cubes to the number of large cubes. So let's say the ratio of small cubes is S is to the number of large cubes is what is given as 4:7. 4 is to 7. And the second information given here is the ratio of the number of red cubes to the number of yellow cubes. So the number of red cubes to the number of yellow cubes is given as what? The ratio is given as 3 is to 5. Given as 3 is to 5. So you have to explain why the minimum possible number of cubes in the bag is 88. So you have to prove that. So how can you prove that? So we already know there can be small red, or small yellow, or large red, or large yellow. These are the possibilities. Okay, so let's say the ratio is given. So let's assume that the ratio is 4x is to 7x, where x is an integer multiplier. Okay, so this is 4x is to 7x, and let's assume that the ratio of red to yellow cubes is what? 3, because there is a different y. So I'll give 3y is to 5y, where y is another integer multiplier. Okay, so the total number of cubes should be what? The total number of cubes should be 4x plus 7x. 4x plus 7x, which is 11x. So this is the total number of cubes, and also the total number of cubes can also be what? 3y plus 5y. 3y plus 5y, because they are either yellow or red, they are either large or small. So this is 8y. So this is also the total number. So the total can be either 11x or 8y. So we can obviously write what? 11x equals 8y, right? This is the total number. So we know that because x and y are multipliers, and the coefficients are what? 8 and 11. So if we do the LCM of 11 and 8, we get what? If we do the LCM, we get what? 11. If I do 8, 8 divided by 8 is 1, and if I do 11, then 11 divided by 11 is 1. So the LCM should be what? 8 multiplied by 11. So the lowest common multiple should be 88. So the least number of bags that has to be there should be 88. That is the minimum number. Before going to the second part of the problem, I just want to highlight some further explanation on why the least possible number of cubes in the bag is 88. So as you can see, the two ratios were given were 4 is to 7 and 3 is to y. Small is to large and red is to yellow, and 11x equal 8y. As you can as we have figured out, x and y are positive multipliers. So if 11x and 8y are equal, I can also write, if I take 8 here, so I have to divide. So y equals what? 11 by 8 into x. Now as we know, x and y are definitely integer multipliers. So for y to be an integer, x has to be what? X has to be a multiple of 8, because there is 11 by 8. So let's assume x is 8k, where k is an integer constant. So if x is 8k, we can write what? 11 by y equals 11 by 8 multiplied by 8k, or y equals what? Y equals 11k. So now for k, for x and y to be minimum values, k has to be what? K has to be minimum value, which is 1. So if k is 1, y equals to what? 11 into 1, which is 11. So y is 11 and x is what? 8 into k, which is 8 into 1, which is 8. So x, the value of x is 8 and the value of y is 11. So as we did the LCM of 8 and 11, so the least possible number of least possible number of cubes in the bag should be 88. Now we'll focus on the second part of the problem. So the second part of the problem says all the small cubes are yellow, so you have to work out the least possible number of large yellow cubes in the bag. Large yellow cubes in the bag, the least possible number of large yellow cubes. So as we have already highlighted that the value of x and y, the integer multipliers, are 8 and 11 respectively. So in order to figure out, we have to first look at the ratio that were given. The ratio of the number of small cubes to large cubes is 4:7, and the ratio of red cubes to yellow cubes is 3:5. According to the ratio, the number of small cubes is what? 4. So the 4 portion, which is 4x, that we already did. So if x, the value of x is 8, so we get what? 4 multiplied by 8. So the total number of small cubes is 4 multiplied by 8, which is 32. And similarly, the large portion was 7, 4:7. So we assumed it as 7x, and we figured out the value of x is 8. So 7 multiplied by 8 is what? 56, which is the total number of large cubes. So this is the total number of small cubes, this is the total number of large cubes. And similarly, the ratio of red cubes to yellow cubes was 3:5. So we assume 3y, and we have figured out the value of y is 11. So 3 multiplied by 11 is what? 33, which is the total number of red cubes. And similarly, we figured out the total number of yellow cubes, which was 5 portion. So 5, we assume that as 5y, and we have figured out the value of y is 11. So 5 multiplied by 11 is what? 55, which is the total number of yellow cubes. So this is the total number of yellow cubes, this is the total number of red cubes, this is the total number of large cubes, this is the total number of small cubes, according to the value of x and y that we figured out. Okay, so the key information given here is all the small cubes are yellow. So all the small cubes, which is 4x, which is 32, so all the small cubes are yellow. So if all the small cubes are yellow and all the large cubes are 56 in total, all the large cubes are 56 and all the small cubes are yellow, so the remaining part, if we look at here, so this is the number of red cubes, and this is all the total number of yellow cubes. Okay, if you want to figure out the large yellow cubes, the least possible number of large yellow cubes, so the total number of yellow cubes is 55, or the total number of yellow cubes is 55, and the total number of small yellow cubes is 32. So the total number of or the least possible number of large yellow cubes is what? 55 minus 32. This is one way of figuring out the total number of large yellow cubes, which is what? 23. Another way is if all the small cubes are yellow, if all the small cubes are yellow, that means what? The red cubes are what? All these red cubes are large. Okay, so if all these red cubes are large, and this is the total number of large cubes, so the remaining large cubes are yellow. That means the total number of large cubes minus the total number of large red cubes equals to the total number of the least possible number of large yellow cubes. So either way, we get what? The least possible number of large yellow cubes is 23. This is how we figure out this problem. Hopefully by now you have a solid understanding on the mathematical topic of primes, factors and multiples. So in the next video I'll come up with another interesting mathematical topic, so stay tuned for that.